This graphic organizer is to help you prepare for your test on Tuesday. Please do this with me. If you don't have these notes, they are in the back of the classroom on the chalkboard tray. Also, I will upload the PDF and you can print it at home. But let's practice a few of these new rules that we have. I am going to skip the first one for right now, only because that's not something that we've been really working on lately and it's not on your test at this point. The product rule, that was the first rule we learned. And what we decided was that if the bases here were the same, all that we had to do is add the exponents. So would you please write on your paper x to the a plus b. That's how we remember this. Don't forget, if you get on a test and you can't remember, you can just write them all out. For example, in number 1, I have h to the second times h to the sixth. Well, that means I have h times h here, and I have h times itself 6 times. How many h's would that be altogether? That's going to be h to the 8th. Now in this next one, we have a coefficient in front. So let's start with that. Even though this looks really, really scary, it's not bad at all. It really isn't. So please, let's multiply the coefficients first. We have -2 times 7. That's -14. Now let's look at a squared and a cubed. We're multiplying them. The bases are the same, so we keep the base, excuse my handwriting, and we have a to the second times a to the third, which means 2 plus 3, so there are 5. So it's a to the 5th. Now I have a 1b here and I have 1b here, but even though the ones are not written in, you know they're there. So b stays because the bases are the same. And I have 1 here and I have 1 here. 1 plus 1 is 2. Let's go to the next one. The power rule was a very recent concept. And unlike the product rule, if you look, these are separated by a multiplication sign. These are not. It's an exponent brought to an exponent. That's why it's called power to a power. So all that we do in this one is now we multiply. So we're going to do a times b. So on your paper, make sure you write x to the ab. That means you're going to multiply. So a nice simple one for number 1. X to the second to the third. So that just means I'm going to keep the base. And I'm going to multiply 2 times 3. 2 times 3 is 6. Now in this next one, I want you to look at this. We have -2m to the 5th. The entire thing in parentheses is brought to the second power. So we have -2 times -2, which gives us 4. Oops. And then I have m to the 5th to the second. So I keep my, I keep my base. And I have 5 here brought to the second power, so that's a 10. Okay, we've got this. That's a 10, by the way. And I'm multiplying that to m by m to the third. Okay, I don't have the power rule here, but I do have our product rule that we learned up here. The bases are the same. So I rewrite the 4, and I keep the m because that's the base, and I simply add the exponents. 10 plus 3 is 13. Take a minute and pause the video. Make sure you have everything I have. Even though my paper is now blank, it just seems to do that when I click on my mouse. We are leaving off at the quotient rule. We just did the power rule. So on the quotient rule, it's very similar to our product rule, except that this time when we keep the base, we don't add the exponents, we subtract them. So it's a minus b. Please make sure you have this rule on your paper, and then let's try a few. Now, number 1 is a little different because it has coefficients on the top and the bottom. Now, keep in mind it is division, but because we have 27 over 42, that's the first thing we're going to take care of. So it doesn't seem like 27 would go into 42. 2 or 42 into 27, and they don't share a lot of common factors, but 3 I know will divide both, so I'm going to start with that. 3 goes into 27 9 times. 3 goes into 42, pretty sure 14 times. Now the next one is the x. There is an x on the top and an x on the bottom, so the bases are the same. We keep the bases. And the only thing we do here is subtract. And a common mistake is to forget that there's a 1 on the bottom here. We do have an x, so it does have to the first power here. They just don't write it in because it's assumed. So 5 minus 1 is 4. Okay, let's try the next one. On top, we have y to the second. So we have y to the fourth. The denominator is also y to the fourth. Oh, this is interesting. Well, let's see. I think we keep the base. If we keep the base, that also means we have to subtract the exponents. Okay, so let's write that out. I almost always write the subtraction ones out because it becomes a little bit more confusing. Oh gosh, I have 4 minus 4, so I must have y to the 0. Oh. Whoops, oh gosh, that's a 0. What's anything to the 0 power? Yes, it's 1. You know how I know that's true? Because anything divided by itself is 1. By the way, let's clean this up. Make sure your notes are not as messy as mine. That should be y to the 0 power. Our last rule and the most challenging is the negative exponent rule. The negative exponent rule simply says to rewrite this as a positive exponent, you put the base under 1. So we write 1 over x to the a this time, because when you write it as a fraction, the negative exponent disappears. So let's keep that in mind. Okay, we're back here and we were doing some practice. I lost everything when I used my mouse for a second, so let me rewrite the rule. This means 1 over x to the a. Gets rid of our negative exponent. Okay, let's try some together. Number 1, if you look at number 1, only the x has the exponent. That's not included with the negative 5. If it was, it would have parentheses around it. So we keep the negative 5. It also says that x is being brought to the negative second power. So I need to write that underneath. So now I have negative 5 over x squared. And for now, that's all there is to do. This next one, we have 4k squared over 8k squared. So let's simplify the coefficients first. 4 and 8 both share a common factor of 4. So if I divide 4 by 4, I just get 1. If I divide 8 by 4, I get 2. So I'm going to write the 2 underneath. And I'm not going to write the 1 quite yet. And I have k squared on top, and I have k to the 5th on the bottom. It looks like I have more k's on the bottom. So it looks like I have, I actually will put the 1 up here so we don't get confused. If I just write this down here so you can see, I have k to the 2nd divided by k to the 5th. Now remember, if our bases are the same, we subtract. 2 minus 5 is going to give us a negative 3. So if it's a negative 3, I simply write that on the bottom. So it's k to the 3rd. Remember, that's how we get rid of that negative exponent, which also makes sense because if you were to really think about this part of it here, this means I have k times k on the top. Oh gosh, that's a k. And I have 5 k's on the bottom. Okay, bear with me. You might want to do this on your paper as well so you can remember why it works this way. These become simplified and we can cancel them out. They're a fancy form of 1. And what am I left with? I'm left with 3k's on the bottom, which means there's a 1 on top, which would be 1 over k cubed, and that's what we have here. Please don't lose these. If I were you, I would stick them in your binder and prepare for this test on Tuesday. Good luck.